In our previous video on LLM benchmarks, we talked about why leaderboard results shouldn't be taken at face value. The field is experiencing rapid growth, and everyone's eyes are peeled for this next big thing, causing the unfortunate trend where being ranked first on a leaderboard is the biggest flex, often at the expense of other important factors such as usability or safety. Companies and research labs resort to tricks and sacrifice the evaluation integrity for the sake of chasing the benchmark result. The reported results are more often than not irreproducible, especially among proprietary models. Crucial details about the exact method of evaluation might be missing, or models which are compared against each other are evaluated using different techniques. I think it's really important to ask, how do these benchmark results translate to industrial performance? What implications does this 1 percentage point difference on the MMLU benchmark have on the end user satisfaction when interacting with your LLM-powered application? The actual preference, as it usually happens, is very subjective, and it depends on the use case. The best model on the market might not be the model that most people use, or it might just not be the best model for you. So let's delve into the reasons why leaderboard better isn't always performance best and what to consider. So one aspect of LLM performance which isn't apparent from benchmark results is answering questions like, is the model obedient to the system prompt? Is it easy to jailbreak it, to make it produce hate speech, toxic content, or make false promises? Red teaming is a form of evaluation that elicits model vulnerabilities that might lead to undesirable behaviors such as leaking personal information. The models are retrained on the outputs of those evaluations to make them more obedient and more likely to steer away from the undesirable outputs. Red teaming can be very compute and human resource intensive and is done more extensively by companies which can actually cover these resources. This results in some models being less harmful and more obedient than others. This is a very important consideration for production-grade applications, and we have seen this backfire time and time again. Next up in the qualitative metrics is the style of responses. Now, this one is ultimately down to personal preference, and to truly get a feel for how you like the style of the responses, you will need to talk to the LLM yourself. Some say that Anthropic's cloud models are more wordy than GPT models, others might just prefer Gemini or Mistral. And yes, all these models have ingested literally the entirety of the publicly available internet, but there are some differences in the feel of the text that they generate, probably due to the different approaches to fine-tuning. The chatbot arena is an interesting qualitative leaderboard where users can blind test different models, both proprietary and open source responses. Another important factor is context length. This is especially important for retrieval augmented generation based applications where the model uses some context to generate responses. Different models can ingest different amounts of input text at once. This input size is called context window or context length. For instance, Gemini 1.5 Pro has a staggering 1 million tokens context window. Claude 3 from Anthropic has a notable 200K context window available to the public, but there's an extended context window of 1 million to be granted to some customers, possibly enterprises. Now, let's put that in perspective. 1 million tokens roughly is the same amount as 5 longer books. Now, on the flip side, there's models like Llama 2 or GPT-3 which oscillate in the 8 to 16K context window range. Now, if your use case involves ingesting and reasoning over large bodies of text, for instance, multi-document question answering, you will find some of the shorter context windows constraining. Does this mean that you can just brute force it, jam-pack information into the LLM and press play? No, even though that's what some model providers are promising. Engineers at LangChain have conducted an experiment in which they examined the model's ability to recall specific pieces of random text intentionally placed in a very large context. And they have found that retrieval in long context isn't really guaranteed and wanes when the LLM also has to reason over the large body of data. Another study titled Lost in the Middle: How Language Models Use Long Context showed that long context LLMs pay more attention to information which fell at the start or at the tail end of the context. Less is really more here. It probably won't improve the performance of the model to add more and more specificities to the guidelines. If you don't see an immediate need for the large context window, you might just choose a model with a smaller context length. Also because the larger the context, the higher the cost and the inference time, which makes latency higher. Which brings us to the next point: inference performance. Quantitative benchmarks are vital for optimizing the balance between performance and cost in real-world deployments of LLMs, and are one which isn't conventionally part of consideration on the leaderboards. This is especially relevant for models which are available via API. Is the API endpoint reliable, or does it tend to time out, rendering it unusable in production settings? When choosing the model, you should consider whether it meets the operational demands of various workflows. And this brings me to the last point: cost. Bigger and more capable models will be more expensive, both when used as a service and if you host the model yourself, as it's gonna take more computation to run the generations. Sure, Objectively, GPT-4 is better at, for example, reasoning than GPT 3.5, and Gemini 1.5 Ultra is better than Gemini 1 Pro, but its cost is also significantly higher. The actual trade-off between cost and capability which you can allow yourself depends on your use case and how big a role the model plays in your ecosystem. In conclusion, while the allure of leading the benchmarks in the LLM space might seem tempting, it is crucial to dive deeper into what these numbers actually represent in real-world applications. Benchmark scores do provide a snapshot of the model's capabilities under very specific conditions, but they are far from the whole story. As we have seen, factors like qualitative performance, the ability to handle larger context windows, and inference performance are just as critical when determining the right LLM for your needs. When evaluating LLMs for deployment, it's important not just to consider the quantitative metrics from leaderboards, but also the qualitative aspects such as style of response, safety, and obedience to user commands. Moreover, the operational implications like latency, cost, and the computational resources required should guide your decision-making process. Ultimately, the best LLM for your application depends on the balance of these factors, tailored to your specific use case. It's not always about having the most powerful model, but rather the right tool for the job which aligns with your operational constraints and user expectations. Always remember, the most celebrated model on the leaderboard might not necessarily translate into the best fit for your needs. Keep these considerations in mind to make informed decisions that go beyond the leaderboard and ensure that your investment in LLM technology truly benefits your users and enhances your application. And if you still haven't seen the previous video about why you shouldn't trust LLM benchmarks, we're gonna link it right here for you.